In this video, we will go over graphical limits. Example 3. Use the graph of f to find a given limit. When necessary, state that the limit does not exist. This part right here, in our class, we talked about in order for limit to exist, the left-hand limit and the right-hand limit must be the same. So if they're not the same, we're going to say that the limit does not exist, okay? All right, let's start with the first one, but do remember how we used the arrow notation. For example, when we had x is approaching, well, actually the first part. Let's go over this one right here. The part that I circled, we have x is approaching -4 from the left. Okay, so reading is important. Being able to read what these notations are saying, that's how we understand what we are finding in this problem, right? So x is, I'll just write down the first one, okay? X is approaching, what number? -4, that's the number, right? -4, okay? From the left or right? Left. How do I know that this is saying approaching from the left? Because of this minus sign. So you need to make sure that you look and see if you have these directions. Because if you have a minus sign or a plus sign, we're looking at one-sided limit. So let's take a look at the first one in the picture. So let's try to start from somewhere on the left of -4, like somewhere in -10-ish, and try to go to -4. Let's see, I'm following the graph. Where is negative? By the way, -4 is right here. So if I'm trying to go to -4 from the left side of the graph, left side of -4, it's trying to approach what number is that? You see the y value is 6. So this equals 6. So what we were trying to find was start from somewhere to the left of -4 and then try to go to -4 and see what the y value is. Okay? So that's how we can read the one-sided limit graphically. All right, let's try another one. Now this time, if you see, we are approaching what? Approach -4 from the, which side? Right. We're approaching that from the right this time. And how do we know that? Because of that tiny plus sign right there. Okay, so somewhere to the right side of -4. So like somewhere from over here. Okay, I'll try to go to -4. As I'm getting closer and closer and closer to -4, I can see that the y value that they're trying to approach is what? This is 4. So the right hand limit as x approaches -4 is +4. All right. So what will you say? Now this time, the general limit as x is approaching -4. Now in order for this to exist, the question is, does it exist? Okay, does it exist? In order for the general limit at -4 to exist, the left hand limit must be equal to the right hand limit, right? Are they equal to each other? Let's take a look at the answers from the previous parts. 6 was the left-hand limit, and 4 was a right-hand limit. They are not the same, right? Well, because 6 does not equal to 4, we say the limit, this general limit does not exist. Okay, DNE, well, I'm just going to abbreviate it to DNE, but the limit does not exist. And if you want to give us a reason, give a reason, because the left limit, the left-hand limit, I'm going to be out of room, does not equal to the right-hand limit. That's why. Okay, so if they were the same, then we get to write down that it exists and it equals to that number. All right, so hopefully we get to see a case where it actually exists. Okay, how about part D? X is approaching what number? Approach +8 from the left. Okay, from the left this time because of this minus sign, right? So where is negative, I'm sorry, not negative 8, positive 8 on this graph? This is 5, 6, 7, 8. So I need to start from somewhere on the left and try to approach this point right here. So somewhere on the left, and I'm going to try to follow this graph, and I can see that we are approaching this point, which is 4 for the y value. So the limit is 4. The limit is 4. And it doesn't have to be a closed circle. It's approaching. It's never going to get to y value of 4, but it's getting infinitely close, right? I mean, if you look at the y values, it's going from like 4.1 and 4.01, 4.001. You see, it's getting really, really, really close to y value of 4. So that's what limit is. It doesn't really have to go and hit that 4. It's just getting really close to that. All right, how about the next one, which is asking for the limit as x approaches 8 from the right. At some point, I'm going to stop writing this down because you will understand what these plus or minus signs mean in one-sided limits, right? If I try to approach 8 from the right, well, you see, I'm going to the same place. Okay, I'm going to the same open circle right there. So this time, the right-hand limit is also 4. Now, look, the left-hand limit was 4. The right-hand limit was 4. So, does the limit exist? 4 equals 4, right? The left-hand limit equals the right-hand limit. Therefore, when they ask you for limit of f of x as x approaches 8 from either side is equal to 4. It does exist. Because, and I get to say because, you know, if you want to write these notations down for just extra practice, because I can say that limit as x approaches 8 from the left of f of x, or no, the function name is big f of x, because big f of x is equal to limit as x approaches 8 from the right of f of x is equal to 4. Okay, I'm saying the left-hand limit and the right-hand limit are equal to each other, and they were both 4. Therefore, the general limit is 4. Okay, alrighty, let's look at the next one. Well, this one is not really a limit question, right? We're just evaluating function. So if x is 5, I'm sorry, not 5, x is negative 4, what is a y value? Okay, because, you know, you've seen this before, f of x. That means find the y value corresponding to that x value in the parenthesis. So if x is negative 4, what is the y value? Let's take a look. X is negative 4, negative 1, negative 2, negative 3, negative 4. And you see we have two circles. We have one open circle at positive 4, and we have a closed circle at 6. We go with the closed circle. We have a closed circle at negative 4, 6, right? Right there, hello. So, the function value is, so f of negative 4 is equal to 6. Okay, that wasn't bad. Okay, let's take a look at the next one. Well, they also want you to evaluate function one more time over here. They want you to find the y value for x equals 8. We need to find a closed circle. Let's see. On the graph, here is 8, but we got a problem. There's only an open circle here. There's no closed circle. So, open circle means we don't really have a y value over there. We don't really have a point there. So, unfortunately, f of 8 is undefined. Okay? Because there is no point. There's no point. There's only an open circle at, it was going to be like 8, 4, right? It would be, at 8, 4, we don't have a really, this is an open circle. So that's why we have to say, because it was an open circle, that it is undefined at x equals 8. All right, let's do the very last one. They're not even asking for the left-hand limit or the right-hand limit. They just want you to find the general limit So you have to look at both the left and the right side and see if they are going to the same place. So let's go find that 5. Here is 5 right here. So from the left, I am approaching this point. Okay? From the right, I am also approaching that point. You see they meet right there. When function is continuous, limit does exist. But the converse does not always work. So when we get to talk about something called continuity, we will talk about that fun stuff. But for right now, we can see from the picture that from the left, as I'm approaching x equals 5, my y value is approaching 7. From the right, as I'm approaching 5 from the right, my y value is going up to 7. Therefore, I get to say limit of f of x as x approaches 5 from either side is equal to, what was the number? 7. So that's how you can do this. Okay. If that's true, just adding extra stuff, what we know is that, and we saw it from the picture, limit as x approaches 5 from the left of f of x must be equal to limit of f of x as x approaches 5 from the right must be equal to 7, because they were both going to that same place. Okay, so that was one example. Example 3. What I want you to do is I want you to stop the video. Actually, let me stop recording. I want you to stop and try these problems, okay? I want you to try these A, B, C, D. Wow, this is kind of long. So I want you to try page 4 on your own. And what I will do is I will start another video and then I will record the answers. And you know what? What will be the best way? I will first start with I'll share the answers and let's do that. How about I just give you the answers, after you try it, you grade it yourself and you let me know if you need me to go over anything on this try section, just like how we are doing it in class. So if you want to add a comment to that page that I'm going to add this link, that will be great. Or you can just type a quick comment on this YouTube video link, that will be fine. But I want you to try this picture now on your own and come back and check your answers in another video, okay? All right, I will be back soon.